Hi friends, today I am going to discuss how to solve a linear programming problem using Simplex method. So first of all, what do you mean by Simplex method? Simplex method is an algebraic procedure of solving a linear programming problem which ultimately gives the optimal solution. Now let us consider one numerical example how to solve a linear programming problem using Simplex method. Suppose maximize z is equal to 3x plus 2y subject to x plus y less than or equal to 4, x minus y less than or equal to 2, x comma y greater than or equal to 0. So this one is called as the objective function and these two are called as constraints, and the last one is non-negative restrictions. In Simplex method, first of all you have to identify the objective function. Generally the objective function is maximization itself. Suppose if it is in minimization form like this, minimize z is equal to 3x plus 2y, then you have to convert minimization z to maximization z on multiplying both sides by minus sign. That is, minus minimize z is equal to minus 3x minus 2y, and this minus minimize z is taken as maximize z. So in that way one can convert minimization form to maximization form, but here the given objective function is maximization itself. Second point is you have to verify the right hand side constants. All right hand side constants should be always positive. If any one of the right hand side constant is negative, then multiply the corresponding constraint only by minus sign. And third step is you have to convert the inequality constraints into equations by the introduction of slack variables. That is, first constraint is x plus y less than or equal to 4. So I will add one slack variable s1 equal to 4. Second constraint x minus y, I will add one more slack variable s2 that is equal to 2. So x, y, s1, s2 all are greater than or equal to 0. So slack variables are nothing but the variables which convert the inequality constraints into equations. Hence, the standard form of LPP becomes maximize z is equal to 3x plus 2y plus 0s1 plus 0s2 subject to x plus y plus s1 equal to 4, x minus y plus s2 equal to 2, and x, y, s1, s2 all are greater than or equal to 0. So this is called as standard form of LPP. Once you identify the standard form of LPP, the next step is you have to find out the initial basic feasible solution by equating x and y as 0, so that we get the basic solution as s1 equal to 4 and s2 equal to 2. Now we have to verify whether the above basic feasible solution is optimal or not. For that, we have to construct the starting simplex table. That is, CB means cost of the basic variable, B means basic variable, x and y, these are the decision variables, and the slack variables s1, s2, and right hand side constants bi. So under the basis you have to write down s1 and s2. Corresponding cost of the basic variables are s0, 0. So here I will write down the cost of the variable Cj, that is 3 and 2, and S1 price is 0, S2 price is 0. I'll write it here. Here I will enter the coefficients of the variables in the constraint. So x coefficient 1, y coefficient 1, s1 coefficient 1, s2 is absent 0. So right hand side constant 4. In the second constraint, x coefficient 1, y coefficient minus 1, s1 absent, s2 0, s2 1, and this is 2. Find out Zj. Zj means summation Cbi into Aij values. Summation Cbi into Aij values. So these are Aij values. So this is called as body of the table. 0 into 1 plus 0 into 1 0. 0 into 1 plus 0 into minus 1 0. So all are 0. Next find out delta j. So delta j means Zj minus Cj. Cj values here, Zj values here. So 0 minus 3 minus 3, 0 minus 2 minus 2, 0 0. So what is the optimality criteria? If all delta j values greater than or equal to 0, then the solution under test is optimal. If any one of delta j is negative, then the solution under test is not optimal. Here the solution under test is not optimal because delta j values are negative. So once the solution is not optimal, find the entering and departing variable from the basis. So how to find out the entering variable? The entering variable is the minimum of delta j values. So among these values, most minimum is minus 3. So I will put a arrow mark like this and block this column like this. That means the variable x enters into the basis. Similarly, find out the departing variable. So departing variable is chosen such that minimum of Aij, that is 4 divided by 1 4, 2 divided by 1 1. So most minimum is here 1. So I will put a arrow mark like this and block this row like this and name it as pivotal row. PR means pivotal row. This is called as PC, means pivotal column. The intersection point, this is called as pivotal element. This is called as pivotal element. So in the next table, you have to make the pivotal element as 1 and all other elements in that column as 0 by proper operation. That is CB, B, X, Y, S1, S2, BI and BI by Aij, just like to the previous table. And here Cj values 3, 2, 0, 0. So here the pivotal element itself is 1. So this is the entering variable. This is the departing variable. That means in place of S2, X enters into the basis. So I will write it as X here. This is S1 as it is. So this is 0 and X coefficient is 3. And again find out Zj and delta j as usual manner. Pivot element is 1 itself. So I will write down the old row as it is here. Make the other element as 0 by proper operation. I will consider OR and new R. OR means old row, NR means new row. New row means this one, 1, minus 1, 0, 1 and 2. Old row means here, 1, 1, 1, 0, 4. So pivotal element position is this one. You have to make this element as 0 by proper operation. that is subtraction, so that 1 minus 1 equal to 0. This is 1 minus of minus 1 equal to 1 minus 0 1, 0 minus 1 equal minus 1, 4 minus 2 equal to 2. So write down these values here: 0, 2, 1, minus 1, 2. Now again calculate Zj using the same formula: 0 into 0, 3 into 1, 3, 3 into minus 1, minus 3, again 0, 0, 3. Find out delta j: 3 minus 3, 0, minus 3 minus 2 means minus 5, 0, 0. Again the solution is not optimal because delta j is negative. As usual procedure, find the entering variable, that is minimum of delta j. So I will name it as pivotal column. Block this one column like this and find out the departing variable using the formula bi by aij. 2 by 2, 1, 2 by minus 1, that is not possible because aij should be positive. Therefore most minimum is this one. Name it as pivotal row. So block this row like this. That means S1 departs from the basis. Now construct the third simplex table. CB, B, X, Y, S1, S2, BI and Cj values 3, 2, 0, 0. Now entering variable is y, S1 departs, so y and x. Corresponding prices are 2, this is 3. Make the pivotal element as 1 by proper division. Here it is 2. So proper division means 0 divided by 0, 0, 2 divided by 1, 2, 1, 1 divided by 2, minus 1 by 2, 2 by 2 is 1. Next, make this element as 0 by proper operation, old row and new row. New row is 0, 1, half, minus half, 1. Old row is here 1, minus 1, 0, 1, 2. Pivotal element position is this one. So if you add the two values, it becomes 0. So this is equal to half, this is half, this is 3. So I write down these values here: 1, 0, half, half, 3. Therefore find out Zj: 2 into 0, 3 into 1, 3. Next 2 into 1, next 2 into half, 1, 3 by 2, 1 plus 3 by 2, 1 plus 3 by 2 means 5 by 2. 2 into minus half means minus 1, 3 into half means 3 by 2, that means 3 by 2 means 1 and half, minus 1 means half. Find out delta j: 3 minus 3, 0, 2 minus 2, 0, 5 by 2 and 1 by 2. Now you observe that all delta j greater than or equal to 0, hence the solution under test is optimal, and the optimal solution is y equal to 1, x equal to 3, y equal to 1 and x equal to 3. Hence the objective function becomes maximize z is equal to 3x plus 2y, that is equal to 3 into 3, 9 plus 2 into 1, 2, that becomes 11. Thank you.